In this video, we're going to be adding some methods to the AList class. So in the previous video, we looked through this class, and now we're going to be adding some additional methods to the class. Just like anytime you're wearing that developer's hat and operating from the developer perspective and adding code to an existing class, you first want to make sure you have a really good, strong understanding of the class as it is. So make sure you know how all the methods work. In particular, in a collections class, you want to make sure you know how the various add methods work. So our AList class has two versions of a public add method. You also want to make sure you know how the remove methods work. So our class has one public remove method. You also want to make sure you know how any private methods work. In our class, we have ensure capacity, we have make room, and we have remove the gap. So make sure you know how all the methods in the existing code works before you attempt to add new code to it. You also want to make sure you're really familiar with the instance data variables. So we have our array, which we call list, we have number of entries, and those are going to be the two most important ones that we will use in our methods. We've noted here as we discussed that our elements, we're storing our elements in the array starting at position 1. So let's make sure we are consistent with that in our code as well. So we're going to add three methods. The first is going to be a move to end method. So this is a method that takes an existing list and takes the first element and moves it to the end. So you can think about a realistic situation where you might, there it is there, where you might use this method. Let's say you have, sorry about that. Let's say you have a list of something and you want to take the first element off and you're bumping it down in priority and you want to move it to the back of the list, right? So you're going through items and you say, oh, this actually doesn't need to be done now. We can save it for later. Let's put it at the end of the list, something like that, okay? So we're going to have a method public. For now, I'm going to have it be void, and we'll talk about whether we think that's the right return type in a moment. Move to end, and we don't need to take in any parameters, right? Because we're just working on our current list. You don't need to give me any additional information for me to do the task. So we're going to move an element to the end. So what we want to do is we want to take the element in the first position and we want to put it in the last position. Okay, so what is the array index of the first item on our list? It's in position 1, right? So we have our first item on our list is our list at position 1. And what we want to do is we want to move this to the end of the list. Now, what is the position at the end of our list? Well, our current last item is in the number of entries position, right? If we have 5 elements on our list, they're in array positions 1, 2, 3, 4, and 5. So that means we want to take the first item and we want to put it at number of entries plus 1. Right? That's essentially what we want to do. We want to take it and put it at the end of the list, which will be number of entries plus 1. Right? And then what we'd really want to do is we'd kind of want to say, well, now list at position 1, we want to empty that out. But that is going to leave a gap in our array. So what we now need to do is sort of shift everything down. So we'd want to take the element that used to be at position 2 and move it into spot 1. The one that used to be at position 3 and move it into spot 2, and so on and so forth. But that seems like code I've written before. So let me look at my private methods, and I can see here that the remove gap method, that's the method that does exactly what I just talked about. It shifts everything down, right? So we could call remove gap, and we're going to satisfy that precondition because we know that our index is going to be between 1 and number of entries, so that should be okay. So we could just call remove the gap at position 1, and that'll shift everything down. So this code should work for most cases, but let's think about those special border cases. So we'd want to think about what's going to happen if our list is empty, what's going to happen if we have a singleton list, and also notice here that we're adding something to the end of our array. So do we ever have to worry about making sure we have enough room? Well, in order to know that for sure, we'd have to be really comfortable and really understand our add method. So if we take a look back at our add method, we can remember that after we add a new element to our array, we always ensure capacity. So if we look at that again at that ensure capacity method, if our array is full, it doubles it. So at the end of our add method, we should always be able to have enough space, right? So we should be okay. We should be confident that the code we just wrote in move to end is going to work properly. But if we wanted to put an extra check on making sure that we're always going to have enough space, because let's say, we worry that maybe someone else would change the add method so that it worked a different way, and we don't always check capacity at the end of adding, What we could do is we could just say, well, maybe this is a little too dangerous because it really relies on that add method being written exactly as it is now. And what if someone else comes in and changes that add method? Well, so let's just, instead of doing it this way, let's just use the add method and the remove methods as they stand. So let's say, okay, let's take the first item right off the list by calling the remove position 1. Let's remove that first element from the list. And then let's just add it to the end of the list. And if we look back at our add method that doesn't take an integer, we know that that first one adds to the end of the list, right? The one parameter add method adds to the end of the list. So this two combination of calls is another way to write this, and probably a little bit of a safer way, because it uses the existing remove method and the existing add method. So we know that those methods, even if their implementation changes in terms of how capacity is ensured, they should still work properly together. So we'll take the element off the front of the list and add it to the back. Now, what's going to happen if I have an empty list? Well, an empty list is actually a special case, right? So we actually want to check to see, well, if our list is empty, do we want to do anything? We don't, right? If you have an empty list, there's nothing to take off the front and nothing to add to the back. So we only want to do this code we just wrote if our list is not empty. If our list is empty, you could make a couple different arguments. You could say you could throw an exception. You could say, well, if someone invokes move to end on an empty list, that is an error situation, and we want to throw an exception to indicate that. Or you could just do nothing. You could say, well, I'm just not going to make any changes. There's nothing to move to the end, and I'm just going to basically ignore it and just have nothing happen. The other thing you could think about doing is returning a Boolean and saying, well, if you invoke this with an empty list, I'm going to return false to indicate that that move was not successful because there was nothing to move. And if there are things on the list, I'm just going to return true because the move was successful. So a couple different ways. You'd have to kind of think about how this method was designed, what it was really going to be used for, and how you want it to work with the rest of the class. I mean, the other methods in our class are throwing kind of illegal position messages with an index out of bounds exception. But this method wasn't really given an index, so I don't know if that makes sense to do. I think you could make the case either way. I actually think all three approaches are totally valid. Having a void method that just ignores the else, having a Boolean method that returns false, or throwing an exception. So I think any of those would be proper ways to write the method, and you would just sort of have to have a conversation with your client or whatever, whoever's going to be using this method to see what might be the best approach. So this should cover if it's an empty list. We'll just skip over the code we did. What about if it's a singleton list? If it's a singleton list, we're going to remove that one item from the list, and then we're going to add it right back to the list. So that's not a problem. Logically, that's what we should do. If you have one element on your list and you're moving it to the end, the list isn't going to change at all. So that's okay. So this element, or this method rather, will work correctly for a one element list. If we wanted to save ourselves some work, we could add another condition and say, well, if number of entries equals 1, I just don't have to do anything. So we could make this might make things a little more, this might optimize things a little bit, right? We're saying if it's a singleton list, I just don't have to do any work because the list isn't changing. So no changes made for a singleton list. Sometimes Eclipse not so helpful. Wow. Changes made for lists larger than size 1. And then this is empty list. Okay. So that would make a little bit of inefficiency there, but you wouldn't have to include that. You could just, leave the code as is for if it's a singleton list. Okay. So that is a move to end method. The next method we're going to write is a swap method. So this method is going to take in two positions and swap the contents at those positions. So whatever is in the first position, it's going to move it to the second. Whatever is in the second, it's going to move it to the first. Okay. So in general, how do we do a swap? Well, whenever we're swapping two values, we actually need 3 parameters to do that, right? Because we couldn't say, let's see, first position item is list at first position. If I then just said list at first position, oops. If I don't use a third variable, if I just use 2 variables, I've lost the item. I've lost the item that used to be at second position, right? So, sorry, confusing myself a little bit here. The point is that we need 3 variables in order to do a swap, right? So we do need a temporary variable. So let's create a temporary variable of type T. We'll just call it temp, and that's going to be the list at first position. Sorry, let's get rid of that code. Sorry, I was confusing myself a little as I was typing there. Sometimes it's hard to purposefully write code the wrong way because you're so used to writing it the right way. So sometimes when I try to demonstrate it the wrong way, my brain just kind of, it won't let me do it. So let's write it the right way. So let's take the element off the first position in the list and store it in a temporary variable. And then we can say, well, the new element going into that first position is going to be the whatever was at the second position. And now the list at second position is going to be the temp, right? So we take the element out of the first position and store it in a temporary variable. We now take whatever used to be in the second position and we store it in the first position. And then we take that temporary variable, which used to be what was at the first position, and we store it in the second. So this is your typical 3 parameters, or 3 variables rather, that are needed to swap 2 elements. Okay. If you have any questions about why you always need 3 variables to swap 2 elements, post to the discussion board. And I apologize for my little my mistype that happened a moment ago. As I said, sometimes the brain refuses to type things in an incorrect way. So that should be a swap, right? So it should allow us to, again, take the element from the first position, store it in a temporary variable, then put the element in the second position into that first position, and then take that temporary variable and put it into second. So that should swap 2 elements in our list. But what's going to happen if our list is empty? Or what's going to happen if either of these positions are not proper? What if someone sends in -1? Or what if we have 10 elements on our list and somebody sends in position 100? So we do need to think about those special cases, and we need to do some checking for those cases. So what we essentially need to do is, one thing we need to make sure is that these are valid positions. So for us, valid positions are in what range? A valid position is in the range from 1 up until number of entries, right? So we can say, well, if first position is greater than or equal to 1, and first position is less than or equal to number of entries, then it should be valid, right? And then I want to do the same thing with my second position. So actually, because I'm retyping the same thing, it might be useful to create a private helper method, maybe called valid position, and just return whether that position is greater than or equal to 1 and less than or equal to number of entries. So this would encapsulate my logic in one place, allow me to save some duplicated code, and also to put kind of a single place where I'm checking that logic. So anytime, again, you find yourself typing something more than once, it's good to kind of stop and think about whether you can make an adjustment to that for good code maintenance and good code efficiency. And often how you can do that is by putting that code that you're repeating inside a method. And then you can just invoke the method multiple times rather than having to repeat the code. So we'll make sure that both of these are valid positions before we do our swap. And here I have to have it spelled right. Now we could actually also use this new valid position method in some of our other places, right? Like we know inside the, where is it? Inside the, let's see, inside remove gap, do we do that? Well, remove gap, it has to be less than, so that we can't use it there. There was somewhere else I thought that we used that same logic. Maybe not, but it's there for if we need it again in the future. Oh, here we go, in the remove method, right? We check to make sure that this is greater than or equal to 1 and less than or equal to number of entries. So let's just swap that out with our new valid position. So it's a good idea to kind of encapsulate logic like that. Again, if you're going to use it in more than one place, you can put it in a method. And then this is good because, first of all, again, it does reduce the duplicated code. But it also, for someone else coming in here, they can exactly see what defines a valid position by looking at the method. If this were to also change in the future, you only have to change it in one place rather than having to change it throughout your code. So again, anytime you start to find yourself duplicating code, typing something twice, or, heaven forbid, copy paste, stop and think if there's a better way to do it, and there usually is. So returning now to our swap method, we've made sure that our positions are valid, and if they are, we've gone ahead and done our swap. Now, what if this is an empty list and someone sends in, some positions to swap within an empty list? Well, if it's an empty list, number of entries is going to be 0. So no matter what positions they send in, if they send in 2 and 3, those are just going to fail as valid positions. So this check here will actually also cover us if it's an empty list. If it's a one element list and someone sends in that one position twice, we'll end up doing work we don't need to do, but it's okay. It'll just leave the list unchanged. So that's probably okay too. I could see the argument that if someone called swap with a one element list sending in that one index, maybe you'd want to indicate somehow that that was an erroneous situation, but I think it also makes sense to just let the method run. Now, what if it's not a valid position? What should we do? Well, we kind of have those same choices. We could change this. We could leave it void and do nothing. We could change it to a Boolean and return false, or we could throw an exception. Now, for this method, because we're dealing with positions coming in as parameters, I think I'm going to try to be consistent with some of my other methods, and I am going to throw an exception, just like we do here in the remove method. So in my else statement, I'm going to say illegal position given to the swap operation. Okay, so again, it's good to be consistent within your classes. So again, I made that decision here, a different one than I did for move to end, because this is one where the user of my class is specifying indices within the list. And so if they give me indices that are incorrect, I'm going to throw an exception and say, hey, you can't do that. But I could also see the argument for just making it a Boolean or for leaving it void. I think any of those are okay design decisions. So that's our second method. Our third and final method we're going to add to this class is going to be a method that creates a new list and returns all elements on our current list that are less than some specified parameter. So it's going to be a public, it's going to return a list of type T, and I'm going to call it get all less than, and they're going to give me some entry. So I'm going to create a new list. I'm going to look through my current list, find everything on the current list that's less than that element, and return a new list. So for example, if this is what my current list looks like and I sent in the entry of 4, I want this method to return a new list that contains 1, 2, and 3, because those are the elements on my current list that are less than 4. Okay, so that's what this method's going to do. Now, in order to write this method, I'm going to have to be comparing things, right? I'm going to have to take this entry. Let me put that little example back, 4, and I'm going to have to say, is 1 less than 4? Yes. Is 4 less than 4? No. Is 5 less than 4? No. Is 2 less than 4? Yes. I have to compare things in order to do this code. So in order to compare things, I need to be ensured that this type of T, whatever it is, that I can compare it to each other. I can compare two elements of type T. In order to do that, I have to make some changes to my class header and to the rest of my class to insist that an AList can only be created with comparable objects, with objects whose class implements the comparable interface. Okay, so to make that change, I'm going to use that kind of funky syntax that I showed you in an earlier video up in my class header. So I'm going to say that the AList now doesn't just contain T, but it contains items of type T whose class implements comparable. And I'm not going to go into the specifics of how this use of generic works, but this is what it looks like in order to enforce that the items in your collection implement comparable. And the one other change I need to make is in two places wherever I create a new array, instead of creating an array of type object, that's one place in my constructor and one place in my toArray method, I'm going to create an array of type comparable. So those are the two changes I have to make. And again, I'm not going to go into the details of why this is like this for the generics. This is just something you can use. So anytime you want to enforce that the items in your collection must implement comparable, this is the syntax that you should use. Okay. So now let's go back to our get all less than method. And now we can actually write the code, because now we know that whatever class this is, right? We don't know what the class is, but we do now know that the compiler is going to enforce that whatever that class is, it has to implement comparable. Otherwise, I'm not going to be able to use it. So now we know we can go ahead and we can compare two elements of type T. So first thing we're going to do is we're going to create a new list. I'll call it my less than list. And then I'm just going to go through my current list, finding everything that's on it that's less than, and adding it to the new list. So I'm going to just have a loop, starting at position 1, going less than or equal to number of entries. Remember, that's the range of elements on my array, my list array. So I'll take a look at my current item on my list is going to be list at position I. And I want to know if it's less than that entry. So I want to say, well, is the current item on my list, I can compare it to the entry. And what does a compare to method return? Remember, it returns an integer, and that integer is going to be either positive, negative, or 0. If the return value is negative, it means the invoking object is smaller. So that would mean my current item is smaller. If the return value is positive, it means the invoking object is bigger. So that would mean my current item is bigger. And if it returns a 0, that means they're the same. So I want to check to see if that current item on the list compared to the other item is going to return a negative number. That's going to mean that my current item on the list is smaller than entry. And that's what I'm looking for in this method. So in that case, I'm going to take my less than list, and I'm just going to add the current item on the list. One important thing to remind you about compare to is that it does not return -1, 1, or 0. It just returns some positive number, some negative number, or 0. A lot of times that number will be -1 or 1, but there's no guarantee. So you never ever want to compare this to -1. That's incorrect because there's no guarantee that that's what compare to is going to return. If you look at the API on the comparable page, you can see that the only thing that it says it will return is a negative, a positive, or a 0. So you always want to be comparing whether this is less than 0 or greater than 0 or equal to 0, never whether it's equal to -1 or 1. Okay, that's a really important thing. That's a common mistake I see happen with the compare to method. So this should fill up our list, and then all that's left is at the end, let's return our less than list. Okay. Now, how will this work if my current list is empty? So if somebody invokes the get all less than method on an empty list, will anything bad happen? Well, if my list is empty, number of entries is 0. So the very first time my conditional is checked before entering the for loop, 1 is not less than or equal to 0. So I'm just going to skip the whole for loop and just return my empty list, which that's logically what I should do, right? If you're asking me for all the items less than some entry and I have an empty list, I don't have any elements less than that entry, so I'm just going to return to you an empty list. That's the correct behavior. If I have a singleton list, number of entries is going to be 1, so it's going to enter the for loop one time and check that entry, and that should work correctly. So that'll be correct as well. So my border conditions are okay. So this is how I can create a new list and return it. Now I am going to make one improvement, what I think is an improvement to this method. I could leave the return type AList, but what am I actually returning? I'm returning a list, right? I'm returning a collection of elements. Does it matter that it's an AList? Could I have returned some other implementation of list interface, right? Am I using in this method, am I using the fact that it's an AList implementation? Am I using the actual array? Does that matter for what the method is doing? The method isn't, get an array list of all elements less than. It's just saying, get me a list, right? So what I'm going to do is I'm just going to make this method a little more general, and I'm just going to return an element of type list interface. Note that I don't have to change anything else in my code because an AList object is an object of type list interface. It does implement that interface. So if a method is required to return a list interface object and I return an AList object, that's allowed. That's following what is required. But the nice thing about this is, let's say in the future I decide that there's an easier implementation I want to use inside of here. All I have to do is I have to change the code inside my method. I don't have to change the return type, which means anyone else who's using this method doesn't have to update how they're using it. They'll just get back a different implementation of list interface. So this is that idea of programming to the interface, and the idea is that you always want to make things sort of match the most general version of functionality that you need. All I really need here is to return some sort of list collection. It shouldn't have to be an AList, right? It should be able to be anything. And that should be logically what I'm trying to do. So I'm going to have my return type just be a general list type, and then inside I'm going to say, well, just because I'm in the AList class, I'm going to go ahead and use an AList object inside. But that's still returning just all I'm guaranteed to return from this method is just a general list interface object. Okay, so there are 3 new methods to be added to the AList class. We've also got our updated class header now that enforces that AList can now only hold elements of type comparable. So as with all classes, when you create new code to add to an existing class, the very first important thing is to make sure you have a really good understanding of the existing variables and the existing methods and how everything works together so that when you add things in, you can use the existing code and update it appropriately.